Okay, so welcome back. So now we're going to do an example of where we're going to do another trig substitution involving tangent. Okay, so now, first thing I'm going to do is, since it matches the form, right? So I'm going to use my tangent theta. So A is 1, and so this is going to be equal, x is equal to 1 times tangent theta. So in other words, tangent theta can be written as equal to x or x over 1. And the reason why I'm writing it this way as a fraction is so I can write my reference triangle. And so now tangent is opposite over hypotenuse, or excuse me, opposite over adjacent. So this is going to be x1, and then of course the hypotenuse is my form. Okay, so it makes sense. Of course, gotta have my theta. So now I'm going to do my substitution. Okay, so again, here I'm going to let x equal tangent x, and then dx equals secant squared x dx. And so now, if I do my substitution, I get secant squared x dx in the top, and I get 1 plus tangent x quantity squared on the bottom. And again, if I simplify this, I get secant squared x dx 1 plus tangent squared theta. This should be theta, not x. Theta. Oh, gosh, I got x's all over the place. Theta. Theta. Sorry about that. Okay, so now notice that I get my identity here. So again, this is 1 plus tangent squared theta, which equals secant squared theta. So this is going to be equal to secant squared theta d theta over the square root of secant squared theta. And of course, I can simplify this, and it's going to be secant squared theta d theta over secant theta, which is going to be equal to secant theta d theta. Now, at this point, you're going to want to know the integral of secant theta. Okay? You want to know the antiderivative of secant theta. Okay? Make sure you know it. Okay, otherwise, you're going to have to derive it. Okay, now, I'm not going to take the time to show you how to derive that. That's another video. And again, go back to your textbook or do a Google search on integrating secant theta d theta. Okay, if you want to know how to do that. Okay, but it's going to involve having to multiply the top and the bottom by a form of 1, okay? And then you're going to have to solve that. It's going to involve using some u substitutions, and that's where you're going to get the natural log and things like that, okay? So, if you don't want to do all that, and you're going to want to just make sure you know what the integral of this is. So, again, I may have other videos. I don't think I have a video showing you this yet, but there are other YouTube videos out there. One that comes to mind is Red Pen, Black Pen, that goes through a lot of integrals of this and shows you how to do that. Okay, so this here is going to be, so the integral of this is going to be the natural log of the absolute value of secant theta plus tangent theta plus c. Now notice that in the last video, or in a previous video, we had the integral of cosecant. And so remember what the integral of cosecant was. It was the natural log of cosecant minus cotangent, right? So again, if you know one of these, if you memorize one of these, you can also kind of also remember the other one as well, because they're very similar in looking, right? Remember, there's a relationship between tangent, cotangent, secant, cosecant, and things like that, okay? So again, so this is the integral. So now all we have to do is use our reference triangle and put it back in. So let's do that. So this equals, oops, not the integral. So the natural log of the absolute value, well, secant is 1 over what? Cosine. So cosine is what? Adjacent over hypotenuse. So it's going to be the reciprocal of that. So that's going to be the square root of, oops, 1 plus x squared. And of course, tangent is opposite over adjacent, which just gives us x. And now, notice something here. Okay, so let's think about this. So, what happens to this, right? So x squared, well, so again, we want to see if there's any issues with this. And we want to see if we can drop the absolute values. Well, we can drop the absolute values if everything's positive all the time. So here, x squared is always positive. Okay, no big deal. Okay. So this thing will always be positive. Now what about this one? Now if x is negative, it seems like there's a possibility that this thing could be negative, but let's think about this. If this is negative, well, at 0, this is going to be positive. Okay? At negative 1, this becomes 2, and this is negative 1, but the square root of 2 is still bigger than 1, and so this is going to be positive. If I do negative 2, well, this is going to be 4, and this is going to be 5, so this is going to be the square root of 5, which is still bigger than 2. So again, it seems like this is going to be positive for all values. In fact, if you think of it another way, what if this gets really big? Well, it's fine because x squared gets bigger faster. Okay? And the square root of a really big number is still going to be bigger than this because this grows linearly. This is growing faster than that, especially with this. The one that's controlling this thing is the x squared. Okay? So this thing is positive for all values of x. Therefore, we can drop the absolute value signs. Okay, now, lastly, if you want to check this thing, then just take the derivative of it. And so this is actually a relatively easy one to take the derivative of. Okay, so if you want to check it, and again, I highly recommend that you, from time to time, if you're ever in doubt, just take the derivative. You should get back to what you started with. So if we take the derivative of this, remember, this is like a function within a function within a function, so you got to be careful. So we've got a natural log function, but inside the natural log function we've got this, but then inside this we've got a square root function. So we've got to do the chain rule twice. Okay? So the derivative of the outside, which is the natural log, is du over u, right? It's always the derivative of the inside function over the function. Okay, so let's do this. Let's do a u substitution here. And so, in this case here, well, we get the natural log of u, right? Well, the derivative of the natural log of u, right, if we take right? What do you get? In this case here, we get du over u, or we get 1 over u. When we take the derivative of the natural log of u with respect to u, we get 1 over u du. Right? Because we have to take the derivative of the natural log, which is 1 over u, times the derivative of the inside, which is du. Now let's just put back what we have. So this is going to be 1 over 1 plus x squared plus x. Now, we want to take du, the derivative of u. Well, what's u? U is this. So what's the derivative of this? Okay, now that's the next step. So the derivative of this, well, the derivative of x is 1, that's fine. But the derivative of this, we're going to have to do another chain rule. So the derivative of this is the derivative of the outside. Okay, so let's do another substitution. Let's do a v substitution, right? So let's say v equals this, right? Okay. So if v equals 1 plus x squared, then dv equals 2x dx. Right? And so what do we do with that? So let v equal that. Okay. So what is the derivative of the outside? Okay. So the derivative of the outside is what? So we get, so this becomes, let's rewrite this. So this becomes the square root of v right? And so what do we get? We get the derivative of this. Okay, so what's the derivative of the square root of v? Okay, the derivative is going to be, what? It's going to be 1 over 2 of v times dv. Okay, now, what's the derivative of v? okay, so let's stop here. So now I'm going to substitute back in for x, right? So what happens here? This becomes the square root of 1 plus x squared. dv, which is the derivative of the inside, is just 2x. So that goes on top. And then the derivative of this piece is just 1. And so that's what I get. Okay, so again, make sure you do this on your own. And again, if you have to do this, if you have to break this out in this further steps to make it clear, that's fine. So now this is going to cancel, right? So now what happens? Well, now I got this thing. Well, it doesn't look like what I started with, right? What I started with was this. So far it doesn't look that way. Well, let's simplify it farther. Let's get this as a common denominator here and make this into one fraction. So let's do this. I got 1 plus x squared plus x. And so now let's get this common denominator by multiplying the top and the bottom by this. So I get x over 1 plus, oops, plus right? And so now I can just combine these and I get and there it is. Because this is the same as this. This cancels this because I'm multiplying, right? So I can cancel the numerators and the denominators here, and I get what I started with. Okay, so it worked out. And that's it. See you next time.